Okay, we are doing homework ACE 4, numbers 1, 27, 30, and 35. So let's start with number 1. Figures A through F are parallelograms. List all the pairs of similar parallelograms. Okay, so let's take a look here. Okay, what I've done is I've highlighted in blue here, I've circled in blue the parallelograms that have equivalent ratios, and then I put an X over the ones that don't belong. So let's talk about why I did what I did. Okay, for A and B, the scale factor is 1.5. So if you multiply 4 times 1.5, okay, you get 6. If you multiply 2 by 1.5, you get 3. So these are equivalent. Okay, but let's take a look at between B and C, for example. Okay, so if I take the 6 meters here and I multiply it by 1.5, I get 9. Okay, so that seems to work there. But if I take the 3 meters and I multiply it by 1.5, that does not equal 4 meters. That does not equal 4 meters. Okay, 3 times 1.5 is going to give me 4.5. So therefore, that's not going to be equivalent. Okay, and so take the same thing here. 2 times 2 will give me 4. 4 times 2, using the same scale factor, gives me 8. So that does not agree here. So that's why C doesn't work. Okay, so let's take a look down here. Now we have just a little bit more complicated numbers to work with, but you'll see that as long as it's the same scale factor, it's going to work. Okay, so between D and F, let's figure out the scale factor. 3.5 times 2 will give you 7 meters. 2.75 meters times 2 will give you 5.5 meters. So that means that this works out perfectly. And by actually looking at parallelogram F and E, you can just eyeball this and tell that this is not even close to being equivalent. Because when you take 5.5 divided by 4.25, you get 1 point da-da-da-da-da. Some other numbers all long drawn out, but you can just look. Look at this shape. Look at this shape. So that's not even close to being equivalent. Whereas with D and F, these shapes are similar. Okay, so for B, what we're going to do is for each pair of the similar parallelograms, which we have figured out, A, B, D, F, find the ratio of 2 adjacent side lengths in one parallelogram and compare it to the ratio of the corresponding side lengths in the other parallelograms. Okay, so for A and B, okay, A, whoops, hold on a second, here we go. A, let's see, 2 over 4. So that's 2 over 4. This is A. That equals 0.5. Okay. For B, it's 3 over 6. So B is 3 over 6, which also equals 0.5. So as you can see, the ratios for A and B are the same. Okay, so let's do it for D and F. Okay, so for D, 2.75 over 3.5 is going to give us approximately 0.786. Okay, so that's approximate. Let me change that to approximate. Alright, and for F, 5.5 over 7 gives you approximately 0.786. 8, there we go. 786. So this is also the same ratio. Okay, so CS says for each pair of similar parallelograms, find the scale factor from one shape to the other, explain how the information given by the scale factors is different from the information given by the ratios of the side lengths. So the scale factor from A to B is 1.5, which we had figured out earlier. So that's 1.5. The ratio is 0.5. All right, so that is different. Let's look at from D to F. From D to F, the scale factor is 2. Okay, whereas the ratio is 0.786. So that is different. The scale factor compares the corresponding sides of two shapes, while the ratio of the side lengths within a shape is compared to the ratio of the corresponding sides in another shape. And so that is how it is different. Okay, number 27 asked, Samantha draws triangle ABC, which is over here, on a grid. She applies a rule to make the triangle on the right. All right. A asks, what rule did Samantha apply to make the new triangle? So let's count the units here. The units for the original triangle is 1, 2, 3 for the base, and 2 for the height. Okay, so it looks like the base is 1.5 here. Let me write it down. I think that'll make it easier for you guys. Okay, so the base is 3, and the height is 2. Over here, the base is 1.5, and the height is 1. So the rule that Samantha made was 0.5x, comma, 0.5y. Let's see how you did that. 2 times 0.5 will give you 1. 3 times 0.5 will give you 1.5. B asks, is the new triangle similar to triangle ABC? And explain. If the triangles are similar, give the scale factor from triangle ABC to the new triangle. So the answer is yes. Y-E-S. They are similar because the scale factor is 0.5. The scale factor is 0.5 from what you see here. So that is similar, and the scale factor is 0.5. Alright, number 30 is multiple choice. The board likes the L-shaped layout but wants a building with more space. They increase the L-shaped layout by a scale factor of 2. For the new layout, choose the correct statement. Okay, it says here, so the scale factor is 2. Let me underline that. Scale factor is 2. That's important. So for A, the area is 2 times the original. As we all know by now, when you're talking about area, we have to square the scale factor. So 2 times 2 is 4, so the area would be 4 times the original. So A does not work. Okay, B, the area is 4 times the original. Well, that's what I just said. So it looks like, and when I say looks like, it looks like the answer might be B, but let's make sure. Let's go to C. The area is 8 times the original. No. 2 squared is 4. And then D says none of the statements above is correct. Well, that's not true either, because the answer is B. Alright, 35. Ooh, it's got parts A through E. Let's get started on this. Okay, 35A. What is the scale factor from the smaller triangle to the larger triangle? Give your answers as a fraction and a decimal. Yippee! Here we go. A fraction. So what we can do is just say this 10 here, which corresponds with this 8 feet here. So we can say 10 over 8, or in decimal format, it can be 1.25. Okay? So there we go. So that's going to be the scale factor. Scale factor is 1.25. Alright? And as far as giving as a fraction, you can just do the same thing. You can say 15 over 12, or you can say 20 over 16. Okay, and that gives you all the same answer, 1.25. Okay, B. B says, choose any side of the larger triangle. What is the ratio of the length of this side to the corresponding side length in the smaller triangle? Write your answer as a fraction and as a decimal. How does the ratio compare to the scale factor in part A? Okay, so the longest side, huh? All right. So the 20 feet over 16 feet. 20 over 16 is going to give me 1.25, and so that's the same as the scale factor. So the ratio is going to be the same as the scale factor. Alright, C says, what is the scale factor from the larger triangle to the smaller triangle? Write your answer as a fraction decimal. So from the larger triangle to the smaller triangle. Okay, so that way it's going to be 8 over 10. 8 over 10 in this matter. So that's going to equal 0.8, because we're going to have to go from the larger to the smaller. So if we're 8 over 10, and that equals 0.8. Okay, part D. Choose any side of the smaller triangle. What is the ratio of the length of this side to the corresponding side length in the larger triangle? Write your answer as a fraction and as a decimal. How does the ratio compare to the scale factor? So I'm going to choose the largest side again. This time I'm going to put 16 feet as my numerator and then 20 feet as my denominator. So 16 over 20 equals 0.8. So once again, the scale factor and the ratios are the same. Okay, so E says, is the pattern for scale factors and ratios in this exercise the same for any pair of similar figures? Okay, so my answer would be, just by looking at our evidence here, would be yes. Okay, so explain. So that's going to be true in general. The scale factor tells by what factor each side is enlarged or reduced, so the ratio of corresponding sides is going to be measuring the same, as in this case and in this case. So I chose two different sides. I chose this side to figure out scale factors and this side for the ratios. And so it's going to be the same, no matter whether it's a scale factor or it's a ratio, when you're talking about corresponding sides. So the ratio of corresponding sides between two similar figures gives the scale factor of the larger figure to the smaller figure, or vice versa.